Okay, I'll explain these notes here on the side in just a second, but we're going to do this with a TI-84. We're going to start finding these binomial probabilities. So binomial probabilities on a TI-84, there's two different ones that we have. We have this one, which is binom, and it says PDF. So this is if x is exactly equal to some number. So this would be like x is exactly 3. Binom CDF, this one's used if we're looking at x is less than or equal to a number. So this would be x is less than or equal to 3. So we're going to have two different ones that we're going to look at here. So when we put this in our calculator, this is going to keep us in order that we're going to enter the number of trials we have, the probability of success, and the number of successes we have. That's the only information that we have to put in. So going back to this problem that we did by hand that took forever, I'm really surprised that took us 30 minutes to do. I'll see you after the video is done. But that took us quite a bit of time here. So that's what I wrote along here is what all these questions are asking. So we're looking at that Pinterest question. So the probability of being success of finding somebody who uses Pinterest is 30%. We had 15 people we're looking at, so we had 15 random trials. So our N is the part that changed. So first we want to know what is the probability that exactly 4 people sampled were using Pinterest. That means I'm looking at X is just equal to 4. Then we hit the probability that fewer than 3 people use Pinterest. So when we say fewer than 3, that means anything less than 3, but 3 cannot be included. So we have X is less than 3. So what that's implying, because when we do binomial probabilities, we're not going to have negative numbers. This is telling me that I'm looking at 0, 1, 2 successes here. More than 1, this is when it was like 2, 3, 4, 5, all the way up to 15. So X is more than 1. X can't be 1, has to be something greater than that. And then D was that we're looking at for the probability that between 1 and 4 people inclusively use Pinterest. So X is greater than or equal to 1 or less than or equal to 4, meaning it could be 1, 2, 3, or 4. So we're going to use this information to help us decide what we're going to use. I'm going to bring this down. We're going to go over to our calculator. Oh, I wish this wouldn't show up over here. Can I get rid of it? Yes, sort of. Well, I can make it easier to read anyway. So where we're going to go is, you notice here it says vars and it says distribution, because what we're dealing with are binomial distributions, like that distribution that we made. So we are going to go to second vars, which takes us to my distributions. So if I go all the way down here and I get to A and B, after I scroll down, we see binom PDF and binom CDF. So for question A is, what is the probability that we have exactly 4 successes? That means that I'm going to use binom PDF. Second, there's something in my way. It won't let me hit enter. There we go. So ask me for the number of trials. So if you remember, we have 15 trials. And we have a probability of success of 0.3. And X is just my value that I'm interested in. So we are going to have 15 trials, a probability of 0.3, and my X value is going to be that 4. So remember, the PDF one, that is used if I'm only looking for one value. So we put in the 5th. So you might also have to put it in like this, 15, 0.3, 4. It just depends on your calculator. So that might actually be what you enter in here. You hit enter. And we get the same probability we got before, 0.21, we'll round it to 9. So B was the probability that we had fewer than 3 people use Pinterest. So X has to be less than 3. So as a reminder, let's go second distributions. Go way down here. So remember, binom PDF is if we're looking for exactly one value. Binom CDF is if we're looking for values less than that number, less than or equal to. So if I said X was 3 here, it would look for X is less than or equal to 3. Now, that is not the situation we have though. We have X is less than 3 directly. So when I do this, remember, because we're talking about these are discrete random variables. If I can't be 3, then what that means is that X could be 2 or less. So I can change this instead of saying 3, X is less than or equal to 2. Because it's not going to be anything between 2 and 3. The next number directly below 3 is 2. So we'll end up selecting that P CDF. And we still have 15 trials. We still have a probability of 0.3. And this time what we're going to enter in is just that 2, because it's going to tell me that probability of 3 or less, or which is the same as X is less than or equal to 2. Like I said, this only works because of the discrete variables. Do not try this later on when we move into continuous distributions. 15 trials, 0.3, and now we're looking at 2. And if I remember, that is what we had last time. So we did this all by hand. We found the probability of 0 people using Pinterest, 1 person, and 2 people using Pinterest. And that was 0.1268. Or we're taking to 127. So we're just rounding my answers. Now, if we look at C, C is more than 1. So once again, we got to think about what this really means. So if I'm doing more than 1, what we're looking at is numbers 2 or greater. But remember that what we're looking for here, or what this is going to figure out for me, this is going to figure out numbers that are less than. So if I do, let me get back to my binom here. Second program, oops, second bars. So if I go back to that B here, 15 trials, we're going to have to figure out what this X is. So I need greater than 1, which means that I'm looking at X has to be at least 2 or greater. But what we figure out here with the binom CDF is this is always values less than. So what this will find for me is values less than. So another way to look at this is if I want this probability, this would be the same as 1 minus the complement event, which is P is going to be 1 or less. So like I said, we're kind of looking at this as what is really happening. I'm going to find the less than event. So the probability of being greater than 1 is the same as being 1, is the complement of X being 1 or less. So we're using that complement event to figure this out. Essentially, we have this. This is my distribution. I want this more than 1. So what I need to do is I need to figure out what less than 1 is to remove it. So it's like removing an area. We're actually going to use that quite a bit later on. So what I'm going to have in here is that I need to just have 1 minus binom CDF. We're going to have 15 trials, probability of 0.3, and this time we're going to put in 1. So if you want to, you can get right to the front of this. Second, insert 1 minus, and hit enter. Oh, it did a times there. Let me do that again. 1 minus, it did a negative instead. Go back to stats. Oh, sorry. Vars. So we're going back to our distributions. Okay, everything's in there. So if I put in 1 minus that binomial distribution, then we see we get back what we had before, the 0.964 or 965. We'll round to that. Okay, so our very last one here is going to be D. So D is going to be a little interesting because D is the probability that we're looking at a value that is between 1 and 4, including 1, including 4. So we're actually looking for like 2 things here. So it's kind of like we're trying to figure out what is the probability that I am going to be between these 2 values. But what we have here is that what's going to be found is I'm going to find less than 4. That's one thing that gets found. Because I can only look at values less than. And I can find less than 1. So we need to do a little fiddling to make this one work. So I'm actually going to go back over here and I'm going to erase some of what we have so I can fit this in here. So for D, probability of this here. So what we're going to do is basically we're going to find this probability. If I find this probability and then I find this probability and I remove it, that's going to give me this area right in here that gives me between 1 and 4. So I need the probability that X is less than or equal to 4. And what I want to remove is the probability that X is less than 1. I don't want to include that one, remember? I need to figure out less than 1 strictly because I need to still have that one that's still included. So I will have binom CDF, and I'm going to have the 15, the 0.3, and what I'm going to start at is 4, because remember it's going to include that 4 and everything less than 4, and I'm going to subtract binom CDF, and it's going to be that 15, that 0.3, and because I want strictly less than 1 taken away, because I still want that 1 included, it's going to be like the other case before, when I'm strictly less than, this is all discrete, I'm not going to put in 1, I'm going to put in actually 0, because that is what's being removed, is just that 0. So second vars. So the calculators help out a lot. You do have to understand what's going on though to use them. Okay, so first I need to keep 4 successes. Then second vars or our distribution, we go back again, and then we change it and we remove a 0. Can't remember if that's what we had last time or not. So we end up with a probability of 0.511. Okay, so I know that was a lot. So I did leave in your notes here how to do each one of these. So you can see the same thing that I entered in again. It just shows you how you do this if you had a TI-84 Silver Plus. So it's going to look a little different there, but like I said, it's just the same idea that we're seeing again. So it brings us back to this one with the multiple choice questions. If we want to put this in my calculator, first we're going to decide what we're actually going to enter in that calculator. So I'm going to write it over the side so when we bring it to our calculator, we can see what's going on. So for A, we want to know what is the probability of, like this is the multiple choice questions one again. So what we had found last time before I even try to do A is that we have 10 trials because we have 10 questions. The probability of a success on a question we found was 1/4, or you could use 0.25. So my first question is, what's the probability of getting a failing grade, which is less than 60%, if you choose questions at answers at random? So this is the probability that X would be less than 6. 60% is 6 questions. So if I was getting a failing grade, less than 60%. So that's PX is less than 60. So remember for this question test, if I don't get a 60%, that means I didn't get 6 questions correct. So below that would be 5 questions correct. So I'm really looking at what is the probability that X is less than or equal to 5. So I would have to do the binomial CDF. And what I'd have is 10 trials, a probability of 0.25 of succeeding, and because I'm using CDF because I'm looking strictly less than, I would have to put in a 5. So like I said, I don't need the 6 because the 6 would be included. I want to make sure that 6 is not included. If we do B, B is what is the probability of getting a 70% or greater? So X is greater than 70. So the opposite of this, another way of looking at this, because we're going to find that we're not going to get that 70, we're going to get less than. So the other way of looking at this is 1 minus. So if I'm not greater than 70 or greater, then I'd have to be getting a 60 or less. Because remember that binomial CDF is always looking at less than. So if 70% or greater means that I get 7 or more questions correct, so X is greater 7 or greater. The opposite of that is that I'd have to have 6 questions or less, and that would be not a 70 or greater. So that'd still be the binomial CDF. So in that case, we're going to have to do 1 minus binomial CDF. We have 10 trials, a probability of 0.25, and we will have a 6 here because I'm removing 6 or less. Then C was the probability of getting between 3 or 5 questions correct. I'm assuming that is inclusive again. So I can figure out what is the probability that I get less than 5 correct. And then I would have to take away the probability because I'm going down to 3 and where I stop is at 3. So then 2 is what I'd start removing. So I'd find the probability of 5 or less, and then I remove the probability of 2 or less, because that's going to leave behind 3, 4, and 5. So this would be binomial CDF 10, 0.25, and 5. And then I'm subtracting from that binomial CDF, and then we still have 10, 0.5, but we're going to remove that 2. So let me get rid of this part here and we'll take this to the calculator. All right, so we do second vars, that takes me distributions. I go all the way to the bottom. And I'm doing the CDF. So now I have 10 trials. I have a probability of 0.25. And for my first one, I want to figure out the probability of getting 60% or less. So that was going to be 5 or less questions. So the probability that I would get a 60%, or not 60%, a failing grade, so that was less than 60, correct? Less than 6. That probability. So if I was randomly guessing, there is a high probability that I'm going to completely fail this exam. There's a 98% chance of failing. So if you go into a multiple choice test and don't study and just guess at random, you'd have a 98% chance of failing. It's not very likely you're going to do well. So B, we're going to have 1 minus, so we go second vars. We go to binomial CDF again. This time we're going to change this to 6. So this was the probability that we made a 70% or higher, so we had a good passing grade, so we're getting a C, B, or an A, B, or C. The probability of that happening is 0.0035. So that means there is a 0.35% chance get a 70 or more. So if you were just guessing at random, once again, without studying, random guessing, it is very, very low probability that you're actually going to pass. And the last one, what is the probability that that we were going to get somewhere between 5 or 3 questions correct? So that one requires me to do this. So I need to figure out second vars. Try again, second vars. I ended up hitting tangent instead. Binomial CDF. We got 10 trials, probability 2.5. And instead of having 6 here, we put 5 because we're going to figure out, all right, what's the probability of 5 or less? And the probability of 5 or less is going to be 0.95. So it's, oh, same thing as we got up here. So we get that 5 or less. And then we are going to find second distribute all the way down one more time. We're almost there. We're going to take off the probability of 2 or less because then that leaves us with that between 3 and 5. So that is going to leave me with 0. Oops, I didn't actually hit enter. 0.5, let's say 5.3. So the actual probability of getting somewhere to between 3 or 5 questions correct randomly is 45 or 45%. So there's a 45% chance that by random guessing, I'd get somewhere between 4 or 5 questions correct. All right, this last part's much quicker, but this is something that we may need quite a bit in the future. So if we are going to figure out what mean, variance, and standard deviation are for a binomial distribution. So we're not going to go too in depth of where these calculations come from. It's a little complicated. Some of it's a little complicated, some of it's not too complicated. So we're going to let x be the binomial random variable and n be the number of trials and p be the number of successes. So if I want to figure out the mean of a binomial distribution, so we got the mean of x. So this is mean of my binomial distribution. So this means if I figure out every single trial, if we have between 0 to n, we find all of those, the mean with that is going to be n times p. So it's just how many trials I have times the probability of a success. Variance is going to be the number of trials that we had times the success times the fail. So that's trials times success. This is trial times success times fail. And then the standard deviation is just going to be the square root of the variance. So the square root of n times p times 1 minus p. So these are all for a binomial distribution. Variance for a binomial distribution, standard deviation of a binomial distribution. So we can just do this very simply with a calculator. We don't have to worry about any special programs. So the probability that a new car of a certain model will require repairs during the warranty period is 0.15. A particular dealership sells 80 such cars. Let X be the number of cars that will require repairs during the warranty period. So what we consider a success is when we need repairs during that warranty period. So what we have here is that the number of trials I have 80 cars at this dealership. I think we're going to sell them all. The probability that before that warranty period is done that this car is going to require repairs is 0.15. So I actually just had this happen. I had to repair something on my car during the warranty period. It was just a sensor. It wasn't a big deal, but those things do happen. So if I want to figure out the mean here, so this is going to be the mean of repairs during, what was it, during the warranty period. Because that's my x's, is how many times I'm going to need repairs. What we're going to have here is it's just going to be 80 times 0.15. So this one makes sense because I expect that 15% of my 80 cars are going to require repair. So that is 12 cars. So this is the mean, sorry, let me rephrase that, the mean of cars needing repair during that warranty period. So during that warranty period, the average is going to be 12 cars. The standard deviation, that is going to be the 80. Let me write this again over here. That's going to be that 80 times the 15, and then we're going to have 1 minus the 0.15. So the times this doesn't happen. So 50% of the time we're going to need repairs, and then that's going to leave me with 85% of the time we're not going to need repairs during that period. This is going to give me a 10.2. So remember, that's in cars squared. Then if I just want the standard deviation, I'm just going to find the square root. So I just need the square root of 10.2. Which is going to be roughly, this one's going to have to be rounded, 3.19 cars. So what I expect is that my binomial distribution, and if we set that all up and we looked at it, we found a mean and a standard deviation, that I would find that the average number of cars, the mean number of cars that are probably going to need repairs during that warranty period are 12, and the standard deviation is 3. So it means like we give or take 3 cars at each end. So it could be somewhere between 9 and maybe 15 cars for the most of the time, 68% of the time. Assuming this is normally distributed. Okay. So going back to the multiple choice questions. Oops. Brought everything back on my screen. So we had 10 trials. The probability of being successfully answering a question is 1 out of 4, or we said was 0.25. So what is the mean for the number of correct answers? Well, that's just n times p, so that is 10 times 0.25. So on average, we expect to get, we are expecting to get 2.5 questions correct, assuming that could happen. What is the variance? So variance was the trials times the probability of success, subtracting the probability, or times the probability of a fail. This is 10 times 0.25 times 1 minus 0.25, or you could have said 10 times 0.25 times 0.75. And that is going to give me 1.875. So if I just want the standard deviation, that is going to just be the square root of 1.875. Which is going to give me approximately, this one's the only one I'm rounding, 1.369. And that is how we're going to find mean and standard deviation. So some of this we will come back to, because one of the things we're going into very soon is just looking at distributions, looking at their mean and standard deviation and figuring out probabilities. So we may do this with events that are binomial. So we need to figure out what means and standard deviations are in binomial distributions.